In this lesson, we're going to be looking at nonlinear relationships, and for our example, we're going to use the data from a Boyle's Law experiment. In this experiment, we measured how the pressure changes as we vary the volume for a fixed amount of gas at constant temperature. We've already labeled our axes with our units, and we've already given our graph a proper title, and you can see that the data is definitely not a linear relationship. So we'll go up to Analyze and choose Curve Fit, and since it looks like an inverse relationship, we'll choose Inverse, try the fit, and you can see that it does fit our data very well, as we would expect it to for Boyle's Law. However, to confirm that this is in fact an inverse relationship, we need to manipulate our data so that we get some sort of a linear relationship with this. So what we're going to do is go up to Data and choose a new calculated column. And for this, I'm going to call it Inverse Pressure. Our short name will be IP, and our units will be the inverse of kilopascals and now to calculate this, we're just going to say 1 divided by pressure. Click Done, and you can see that now a new calculated column has shown up here with all of our values in it. To now graph it, I choose the label on the y-axis and choose inverse pressure, and you can see that it has plotted the data points down here, but let's look at this a little better by auto-scaling from 0, and you can see that now there are all of our data points. We can rescale our axis just a little bit so that we can see all of those data points. And now to confirm that it is in fact an inverse relationship, the inverse of the pressure with the volume should give us a direct relationship. So we'll choose Model and a linear fit and click OK. And again, we don't see the line here. Just zoom out just a little bit and you can find the line. It's going to be this one here. Double click in the box, enable the line drag, and now we can manipulate this line to give us our line of best fit. Let's just move it over here just a little bit. Now we can zoom back in and continue to manipulate our line to give us what we think is going to be our best fit for this. And you can see that with our data, it does line up very well in a linear relationship. And if we were to include our uncertainties, the line should go through the origin to confirm that it is an inverse relationship. So we've taken nonlinear data, manipulated the data so that we can get a linear graph.